Today we're going to talk about domain and range. So domain, as I wrote down, is all the x values, and range is all the y values. So domain is all the values as you travel from left to right in a graph, and range is all the values as you travel down to up of a graph. So then there are two types of notation, set and interval notation, and there are symbols there. And we're going to be using these, but I don't necessarily care if you use them in your homework or tests or anything. I just want you to be able to recognize them if they are written on a test or an SOL. So, an example, if the domain of a graph contains every number. So, let me show you how it would be written in set notation. What you do is you first open up a set. So, set's just like a squiggly line. And then you write x, and then you write that up and down line. That means such that x. And if we were talking about range, we would be using y's as an element of. So, I write an e. And if it contains every number, we use that fancy R, and this is how I write my R, but I don't care how you write yours, and that indicates all real numbers. If we were going to do interval notation, if we look at the chart over here, there's infinity and negative infinity. So if I make a number line, infinity is basically all the positive numbers going in the positive direction, and negative infinity is all the numbers going into the negative direction. So if the graph contains every number, what you do is you write yourself an interval, and it starts at negative infinity, and it goes to infinity. And I close my interval. If the domain of a graph contains every number above or equal to 2, what you do is you open up your set. You always have this x, such that x is an element of. And if it's every number above or equal to 2, it would be all numbers, so all real numbers, above, which is greater than, or equal to, so I write the line underneath it, 2. And I close the set. For interval notation, what you do is, I'm going to draw a little number line over here so you can visualize it. Here's 2. So it includes 2, and it includes everything above 2. So this graph starts at 2, and it goes to infinity. And so since it includes 2, what I do is I put a boxy bracket next to the 2. If it didn't include 2, I put a parenthesis, and I always put a parenthesis next to the infinity. So now let's look at specific types of graphs. So the first type we're going to look at is ordered pairs. So ordered pairs for the domain. Domain is all the x values, so all of those values. And I'm going to write it out, and I'm going to put it in order. So -2, 0, 1, 5. Range is all the y values. So I'm going to, again, put it in order, 0, 6, 7, 8. The zeros are where the graph touches the x-axis, and that is also where y equals 0. So in this case, y equals 0 right here at 5. So 5 is the 0. Now, whenever we're looking at a graph like this circle, miscellaneous, a shape or something, what I'm going to do is this little red thing over here, this red line, is going to be my domain stick. And so I'm going to grab that. So I drag it across the graph, and I see where the first place it touches where it will touch. And so in this case, as I drag it across, it's acting really slow, it starts at -2, and it'll keep touching that circle until I stop at 2 right there. So our domain in this case would be -2 to 2. So now I take my blue stick, which is my range stick, and I'm going to drag it from down to up. So as I drag it up, I'm going to start touching that circle at -4, and I'm going to keep touching that circle until I reach 4, and that's where I will stop touching it. So that means the range in this case would be -4 to 4. So how you would write this is in interval notation. You'd write -2, 2, or -4, 4. If you're going to write the other notation, which I doubt many people will, this is how you would write it. And so the zeros in this case is where it crosses the x-axis, so that's right here and right there. So -2 and 2. So the main idea is that the domain is the farthest left and right, and the range is the farthest up and down. So for square root, I am going to be taking my domain stick, and I'm going to be dragging it across. So I'm going to drag it from left to right again. And so in this graph, I will start touching it over here at -4, and I'm going to keep touching that forever and ever. Notice I extended that arrow so that you can see that it will continue to touch forever and ever. So this means the domain will be starting at -4, and it will be going to infinity. Now I'm going to take my range stick, and I'm going to drag it from down to up. So I'm not touching the graph at all down here, and then I'll start touching it right when I get to the bottom right there at 2, and I'll continue to touch it all the way up. So that means for my domain, if I was going to write it in interval notation, I'd put a bracket, and it's from -4 to infinity, and then the range was starting at 2 and going to infinity. Or you could write real numbers greater than or equal to -4, or real numbers greater than or equal to 2. The zeros, it doesn't have any because it's not touching the x-axis at all. So the main idea is that domain and range is a number to infinity or negative infinity. And actually up here in the circles, I should have made these brackets. I'm not going to be very technical though on tests. Now for absolute value, I also extended my arrows so that you could see that they will keep going. So let me take my domain stick, and I'm going to drag it from left to right. So if you don't have much imagination, you'll think that it just stops at those arrows, but that's why I extend them, because now once I drag it across, you'll see it's touching either the black V or the arrows that I extended the entire time. So that means the domain would be negative infinity to infinity, or all real numbers. Now for range, when I drag it up, it will not be touching the whole time. So it won't be touching it all down here. And then as I drag it up, it'll first start to touch at the axis, and then it will touch all the way up. So that means that it starts touching at 0 at the axis, and then it stops touching, and it goes to infinity. So my domain was negative infinity to infinity, or all real numbers. And my range, it started at 0. It started at the axis, and it kept going up forever. So 0 to infinity, or all real numbers greater than or equal to 0. Zeros, it's touching right there at 3. So now for quadratics, notice I extended the lines again. So as I drag my domain across, it will be touching either the black line or my red extensions the entire time. So it means it'll be the same as absolute value. So now I take my range stick and I drag it up. And so I won't be touching that graph as I drag it up until right there at the bottom of it at -3. And then I will keep touching it the whole way as I drag it up. So that would be -3 to infinity. So again, domain was negative infinity to infinity, or all real numbers. And my range was -3 to infinity, or all real numbers greater than or equal to -3. And so it's touching there and there for the x-axis, so I would say that's about -1.8 and 1.8. So the main idea is the domain's negative infinity to infinity, and range is a number to infinity or negative infinity, depending if it's pointing up or pointing down. For cubic and cube root, since they have the same shape, I put them together. So I drag my domain stick across. It's touching the entire time. Then I take my range and I drag it up. And as I drag it up, it'll be touching one part of the, or maybe multiple parts of the cubic the entire time as I go up. So that means it's also touching the whole time. And so what that means is that for my domain and my range, it'll be negative infinity to infinity, or all real numbers. And this is how it'll always be with cubic or cubed root. The main idea is that domain and range will be negative infinity to infinity. For zeros, there's several of them, -2, 0, and 3. For linear, I drag it across, and it'll be touching the entire time as I drag it across. And for range, I have to drag it up, and that will also be touching the line the entire time as I drag it up. So that means that for my domain and range, both these will be just like cubic or cube root, negative infinity to infinity, or all real numbers. And so the main idea is the same as well. The domain and range will always be negative infinity to infinity, as long as there's arrows on both ends. So for the zeros, it's touching right there at 2. Exponential and logarithmic are a little bit different. If you notice the green highlighter line, I would draw that into your graph. And so what that is called is an asymptote. So if a graph looks like it's kind of shooting into the axis or starting to go straight, what that means is that it has an asymptote. And we're going to learn more about these later, but it's a line that a curve approaches but does not touch. So that green light indicates that that curve is getting really, really close to the axis, but it's never actually going to hit it. So it's acting as a wall. So I still extended my arrows, but as I drag my thing across, I will be touching this curve the whole time as I drag it across. So the asymptote in this case does not affect the domain at all. However, it will affect the range. So as I drag my pen upwards, it will not be touching below that green line because that green line acts as a wall. So it won't be touching anywhere below here, but then it'll start touching right above the green line, and it'll continue to touch all the way up. So, like I said about domain, it was touching the whole time. So negative infinity to infinity, or all real numbers. But a range didn't touch until right above the x-axis. So we will say it's at 0, and I'm going to put a parenthesis next to it because it didn't actually touch the x-axis. And it was going all the way up to infinity, or all real numbers greater than 0. Since there's an asymptote on the x-axis, there are no zeros. So the main idea is that the domain or range, one of the two will be negative infinity to infinity. In this case, it was domain. And the other will be a number to infinity or negative infinity. Last is rational. So these are the ugly ones that have multiple graphs. If you notice, I drew green lines in again. Usually rationals have 2 or more asymptotes. So whenever I drag my red line across, I will be touching that lower left graph until I hit the wall. Ooh, I hit a wall right there. And then after I get past the wall, I'll be touching the other graph the rest of the time. So that means basically I was touching either curve at all times except for when I hit that wall at -1. So then when I drag it upwards, I will be touching that lower graph, and then I will hit the wall right here, and then I will be touching that upper graph the entire way up. So I am touching that graph every place except for when I hit that wall at 0. So how you write that is, for the domain, I was touching for all real numbers except for, so not equal to, wherever I hit that wall at -1. And for range, it was all real numbers until I hit that wall at 0. So the main idea is that domain and range are real numbers not equal to wherever the asymptote is. So when you drag your pen across, it's wherever you hit that wall. That's what it's not equal to. Zeros, since there is an asymptote on the axis, the zeros are none.